record. Okay. All right. So what we're going to do is we're going to explain virtualization on today. And we're going to explain virtualization the Neil Helton way, because I often feel like people are too technical when they explain virtualization. Now, I don't have my pen. I'm using my mouse and it's kind of hard. So kind of work with me. So what we have here is a PC, a personal computer. Now, on every personal computer, we have a hard drive. And I'm going to draw a circle here to represent. It's going to be a bad circle, but we'll straighten it out. Like somebody want to try to help me draw. Uh, all right. So take your time. All right. So on every hard drive, we have certain things on those hard drives. So PC hard drive. The hard drive is actually inside of this PC. Okay. Our hard drive is inside the PC. Now, our hard drive, there's a term that's called formatting. I'm just going to type this in. There's a term that's called formatting. All right. Now, what is formatting? Formatting is when we're trying to prepare the hard drive to for the not I was about to mess up, say operating system. So when we format a drive, we are preparing the hard drive for the filing system. All right, and I'm going to move that over. Preparing the hard drive for the filing system. All right. So that's the whole point of formatting. So when you format a drive, what typically happens is this. Get my pen back. When you format a drive, the hard drive start making grooves. Like if you're old enough, you've seen a record, or if you're into music, you've seen records. So if you had a CD, you looked at the CD and you've seen all these grooves in the CD. The grooves, or what we refer to as kind of like tracks, are there so that we can store information. That was bad. Store information on the actual disk. Okay. So that's what each groove is for. And I'll show a better representation later. I need a PowerPoint, all this stuff anyway. So each groove is used to store information on a hard drive. Okay. So what formatting creates the grooves on the hard drive so that data can be stored there. And that's based on what we call filing systems. Okay. Now, I'm going to go touch on Windows filing system. I'm going to touch on the Apple filing system, and I'll touch on Linux filing system, since those are the main companies that create filing systems that are associated with an operating system. Okay. So when it comes to Apple, Apple uses um, APFS, well, plus, which stands for Apple Filing System. Okay. So Apple uses APFS plus. Windows uses a lot of them, but mainly Windows systems or operating systems use NTFS, and this stands for New Technology Filing System. Okay. New Technology Filing System. So that's NTFS. Okay. Place this here and make it bigger. So that's NTFS. So Apple uses Apple Filing System Plus, or APFS. Windows uses NTFS, or New Technology Filing System. Now, just to go back a little bit, we said formatting prepares the hard drive for the filing system. So that means on the hard drive or the hard disk drive, grooves are created to store information on that particular disk, similar to a record. You know, DJs spin the record, the grooves in the record hold the actual sound file. Same in that as well. And on Linux systems, Linux uses what is called ext4. Okay. So, and this is referred to as a journaling system. So Linux uses ext4. So just to, reiterate, let me see if I can get this to come back up. Apple uses APFS plus. Windows uses NTFS. Andre, you kind of over the the thing, Andre. A new technology filing system, and Linux uses ext4. Okay. So please make note of that because you will have to know that for the exam. The filing system associated with Apple iOS or Apple operating systems are APFS plus. So their hard drives are going to store files according to an APFS plus format. Windows
What does that
system,
stand for again? I'm sorry. The APFS plus.
Apple filing system.
Okay, thank you.
No, it's cool. Let's see if they'll let me write it in. Now I can make it a little smaller. Okay. All right. So APFS stands for Apple Filing System. Windows NTFS stands for New Technology Filing System. And then you have EXT4. So EXT4 is associated with Linux. Okay. And it just stands for Extended File System. EXT stands for Extended File System. Okay. And when you have these hard drives, there's another term that we associate with hard drives. And that term, so we said formatting, the next term is called partitioning. All right. What is partitioning? Partitioning is when you divide your hard drive into sections. And I'll make it more manageable so that you can see it. Okay. Pull this over here. So we have partitioning there, and we have formatting here. All right. I'm just going to move it over there. So there's formatting and there's partitioning. All right. So when you divide your hard drive into sections, I used to tell my high school students, you basically you're going to make your hard drive look like a pizza, where you're going to start to section things off. Okay. We're going to have different sections divided. And this is when we partition our hard drive. Right. And you can have multiple partitions on a hard drive. So if you look now, you have different sections that are associated with that hard drive. Give me 1 second. Let me find my image because I hate the way my drawing looks. Um, paste it here. Paste. It won't let me paste. All right, don't worry about it. I'll show it later. So these sections right here, this part of the hard drive, we refer to that as a sector. All right. So that portion of the hard drive, we refer to it as a sector, this one little section right here. All right. So once again, the grooves of the formatting, the partitioning part is when you start to divide or segment your drive into different sections. Each one of these sections are referred to as a sector. Okay. If you have two sectors or multiple sectors with information on it, we call that a cluster. Okay, cluster. A cluster is multiple sectors. Multiple sectors are referred to as a cluster. Okay, each each one of these revolutions or these these uh these circular motions, this is referred to as a track. Okay, each one of these are referred to as, when it goes around like this, each one of these are referred to as, man, I gotta get my pen working. These are referred to as a track. Okay, and I'll show a better image when I can get to that section. Okay, a track. Okay, so just to give you a little update, so we have what is called smart. So your operating system, or SMART, or smart errors, your computer or your operating system can determine when certain partitions are going bad, or when certain sectors are going bad. So what the computer will do is the computer will blot out, or the operating system will blot out that particular track and say, do not use this track to store information. Okay. The operating system does a lot. So I'm just going to draw until this get kind of deep, but this is going to be a track. So let's say this is a bad sector. You have multiple bad sectors on the hard drive. The operating system will block this out, or block that track out, to say we can't use that track. Okay. So let's reiterate. So you have filing systems that are stored on your hard drive. You have Apple uses APFS Plus, or Apple Filing System. Windows uses NTFS, New Technology Filing System. They use two more as well. Linux uses EXT4, or Extended Filing System. Okay. Now, your hard drive is divided into different sections. As we said, partitioning is when we divide our hard drive into sections. Each one of these sections are referred to as a sector. So your informations can be housed in a particular sector. If you have multiple sectors with information on them, say like a document you've written, or maybe it's a song, or if it's a large program and it's taking up multiple sectors, we refer to that as a cluster. This, if we go around this entire section with all these different sectors, we call that a track. And as we said, there are things that are called smart errors that will actually blot out a track if there's configuration issues on that track. And the operating system will basically tell the computer, do not use that part of the hard drive. Okay. So that's what I wanted to bring up first. So the second thing I want to bring up is that the kernel is the root of the operating system. The kernel is the source of the operating system. Look at it as popcorn or something like that. Okay. When you put the kernel in oil, it pops open. All right. So just using that analogy, your kernel controls everything. This is the root or the source of the operating system. So give me a minute. I'm going to get my eraser, erase this, get rid of that. The kernel is the root of the operating system. The kernel is the root of the operating system. What are you doing there? All right. So once again, if you ever hear what the kernel is the root of the operating system. So think about, and the functions of the kernel are as follows. Okay. What does the kernel do? The kernel performs security. The kernel is responsible for apps and programs. Sorry, I'm having a hard time. Programs. It also controls processes. Now, a app program and a process are different things. Okay. So you can have multiple things taking place on your computer. Those are going to be referred to in most places. The running of a program is a process, and you can have multiple processes taking place on your computer. So, but the ultimate thing that the kernel does, it controls hardware and software. Okay. That's the main purpose of the kernel. The kernel, or the root of the operating system, controls hardware and software. All right. So that's my definition. Okay. So once again, we have a PC. This PC has a hard drive. On this hard drive, you have different, what we call formatting, depending on the operating system or the kernel that's associated with a particular operating system. And you can have a Windows kernel, you can have a Linux kernel, you can have a Google Chrome kernel, you can also have a Mac, okay, Apple kernel. All right, the kernel is the root of the operating system, and its goal is to control security, apps and programs, processes, but more importantly, it controls hardware and software. Okay, so let me just draw this out real quick. Let me move this definition of partitioning, and I'm going to do this. So I'm going to draw this down here and draw this up here, that there, and that there. And then this here, and this here. Then when I do this, we're going to say software. And do another one. Software. Not siftware. Software. All right. So the goal of the operating system is to control software. And you guessed it, the goal of the kernel or the operating system is also to control hardware. Okay. Control hardware. Get out of here. Hardware. All right. So if you ever get a question and I say, what does the operating system or the kernel of the operating system do? What is, we only got 10 people in here. Somebody dropped off. So the kernel, what does the kernel do? Anybody?
Controls hardware and software.
Absolutely. The kernel controls hardware and software. Okay. Now, let me tell you where the kernel sits. Okay. Where does the kernel sit? All right. Yeah, I'm just getting rid of some things and all right. So the kernel of the operating system actually sits in one of these partitions or sectors on a partition. Okay. The kernel sits in a partition, but it sits in one of the sectors of that partition. Okay. So your kernel is on the hard drive. So every time you turn your computer off, your kernel goes back to the hard drive. And you say, Mr. Helton, what do you mean it goes back to the hard drive? Well, every time you hit the power button on your PC, there's a chip on the motherboard that goes and searches for the kernel of the operating system. So it goes, you hit the power button, and then there's a chip that is called your BIOS chip or your UEFI chip. So I'm just going to put a B here, and I'm going to put a U here. And we said that the B stands for Basic Input Output System, and the U stands for Unified Extensible Firmware Interface. So BIOS, U, sorry, UEFI. Okay. Now, these are what we call firmware chips. Okay. These are firmware chips that sit on the motherboard. It's going to make more sense when we actually get into the actual hard drive. Okay, so I know some of you are like, well, when are we going to look? We're going to look at it. You won't just be looking at my ugly drawings. All right. So the BIOS or the firmware chip sends a signal to the operating system to locate the kernel. And what do we say the kernel is? What's the kernel?
Controls the software and hardware.
No, that's what it does. But what is the kernel? The kernel is the
The operating system.
root of the
The
operating system.
source of the operating system.
Absolutely. It's the source, the root of the operating system. So everything is built off the kernel. And what is the purpose of the kernel? To control
Software and hardware.
software and hardware. All right. So the purpose of the kernel is to control hardware and software. Okay. It does other things. Now you're saying all this to explain virtualization? Yes. Because we got to get down to the bare bones of it before all the other stuff makes sense. All right. Now we said this kernel actually sits in a sector in the partition of the hard drive. Now, what do we say the partition does? What does the partition do?
It divides the hardware.
Come on,
It
hard.
separates
Come on. Go
the
ahead.
software.
Well, partitioning?
Yeah.
No, that's what the
Okay.
kernel does.
Okay.
The kernel will control hardware and software. Okay. But
Okay.
your partitioning, when you buy a brand new hard drive, the goal of partitioning is to section off that hard drive. All right. So I'll let me show you something real quick. Dang, that's gonna get rid of everything if I do that. Okay. All right. So I'll show you an image of that in a minute. So let me go over the terms again so that everyone has it. Okay. Your kernel is the root of the operating system. So you need the kernel in order for your computer to work. Okay. You can build your own operating system off of the kernel. If you go down and download a Linux kernel, you can start, if you know coding, you can start to code around the kernel to make applications, programs, and build out the instructions of how the operating system is going to work. Okay, that's the beauty of Linux. Windows and Mac and Google Chrome, they're not going to let you do that. But when Linux will let you build upon their kernel. Okay. We said that this kernel sits on a hard drive. Now, remember, I broke down the hard drive this way. A hard drive has tracks. As we go around track, just like a racetrack. Think about a racetrack. It has tracks. There are sectors in that track are like mile markers. Okay. As you go around the track enough, you know that you've hit a certain mile based upon the mile marker. Okay. So we have different sectors within each part of that track. The tracks are divided by what we call partitioning. We're dividing the hard drive. So you have certain sections. Now, when we say this, these partitions have a drive letter. Okay. So this may be drive D, drive E, drive F, drive G, depending on how you label your hard drive. So we have sectors, little sections. A group of sectors is called a cluster. And when you go around one revolution, you're going around a track. Okay. So just to drive that home, I said sometimes when you have configuration issues, the operating system, the kernel, will blot out a particular track and continue to use that hard drive and tell any program not to be saved there. Okay. So that's one of that. Now, getting back to the BIOS and the UEFI on the motherboard, we call this a firmware chip. So every time you update your cell phone or update your, not the operating system per se, but if you get like there's a 17.1 something update that's for all iPhone users. Mine didn't upload because I have too much, I don't have enough space. So when that chip updates, it's going to erase the information that's in it, and then it's going to upload new information. And sometimes there's going to be operating system updates, program updates, more functionality on the motherboard or things of that nature that's going to take place. This chip is very important. Okay. Now, getting back to this, we said that the kernel sits in one of these sectors, which is in a particular partition. So, once again, I think I should do this to kind of drive home the partitioning. So, when you partitioning, you're creating a drive, or what we refer to as drives, and each drive has a drive letter. You may be on drive A, maybe on drive B, drive C. It just depends on how you are partitioning your um hard drive. Okay. So with this being said, and the kernel sitting on the in the hard drive, so now we know that our operating system really sits on the hard drive. Okay. So, in order for us to create what is called virtualization, what we have to do is we have to go in the BIOS or the UEFI, and we have to enable the ability to use virtualization software. Okay. Or what we call enabling VT, or enable VT, or enable virtualization. Okay. Please stop me if I'm not making sense. I don't want anybody to sit in confusion. So
Can
it
you
said, Mr.
that last
Go
part
ahead.
again for virtualization for a second?
Okay. So if your motherboard allows virtualization, you'll have to access the BIOS or the UEFI. Now, according to your motherboard, when your computer's first starting up, you'll either have to hit the F1, the F2, the F10, the F11, the delete key, whatever it is to access the BIOS. This is before your computer, the operating system comes on, and you see that splash screen. So pretty much you'll probably see something like your what would you typically see? Like on my computer, I see the logo of the computer that's flashing. As the logo is flashing, I'm hitting F2 to access my motherboard's BIOS, or that chip, this chip. Once you access this chip, then you can go in and enable virtualization. But the kernel sits on the hard drive. But let me explain this part. There's something called hypervisor. Okay. There's something called hypervisor.
Because I have a quick question before you go there.
Uh-huh.
Said that if your computer has virtualization, are there some computer models that don't have it?
Yes, that is absolutely correct. There are some models that don't have virtualization. Like my wife's laptop she just bought does not have virtualization on it. If you have a Mac computer, you already have Linux on it. And most Windows computers now become Linux ready. Like you can install Linux on it. But a lot of computers, some computers, not say a lot, some computers don't have the ability for virtualization. It's just not powerful enough. When you have virtualization, you have to have a strong hard drive, a strong CPU, a lot of RAM, a lot of storage space, because you're going to have two operating systems on one computer. And there are different types of virtualization, you know. So in this case, the hypervisor is what we call virtualization software. I keep hitting I. I'm sick of this keyboard. Virtualization. Okay. So your hypervisor is virtualization software. Okay. So that's what the hypervisor is. In order for your computer to actually allow you to virtualize it or install another operating system, you have to install a hypervisor that sits on top of the kernel. So your hypervisor sits on the kernel. And what do we say the hypervisor is? Virtualization software. Okay. So the point of the hypervisor is so that when you install that operating system, that new operating system like Linux, on this Windows hard drive, you can still use the Linux operating system as if you're using your Windows computer. Okay. You can use all of the, as you can see, this hypervisor kernel or virtualization kernel will now use software and hardware. Okay. So you can have a hypervisor that controls software and hardware. Now let's stop and do a check for understanding. What is a hypervisor? Anybody?
Virtualization software.
Thank you so much. The hypervisor is virtualization software. The hypervisor must be installed on the computer. Okay. If it's installed on the computer or the motherboard, if it's installed there, then it will give kernel access to a particular operating system that you're going to install. Okay. And we said the kernel is the what? What is a kernel?
Hardware and software.
Well, that's what it does. A kernel controls hardware and software, but what is the kernel?
Operation system.
It's the what of the operating system?
The root?
Yes.
Okay.
The root is the source. I hate to say it this way. It's the God of the operating system. Okay. So it's the source of everything. It controls it. You know, I hope everybody got that. I know I'm not trying to anyway. I hope that drove it home though. It controls everything. Or we could have said it's the government. It's the government of the operating system. It's the source, it's the root of everything. All right. So, with that being said, your kernel sits on a sector of the hard drive, a sector or a partition of the hard drive. Okay. Not only that, this kernel also sits in a partition. When you hit the power button, the BIOS checks to see, or UEFI checks to see if all components on the motherboard are working. Is the hard drive connected? Is the mouse connected? Is the RAM working? Is the hard drives working? Is the power supply working effectively? Are all the components on the motherboard or any peripheral devices working? Okay. Once it recognizes that, then it sends another signal to the hard drive to find the kernel. It's actually looking for what is called a master boot record or a globally unique identifier partition table. I know it's a mouthful. So, what are we looking for? There are two partition files. One is called a MBR. So, if you're using legacy systems, then the BIOS will use an MBR, or what is called a master boot record. I do S, no. Master boot record. All right. This master boot record gives you the instructions on how to find the kernel on the hard drive. So the master boot record gives you the instructions, which will be in a partition, to find the hard drive or the kernel of the operating system. And these are associated with devices that are from 2013 prior, because in 2013 they created the UEFI. So 2013 to now, most computer systems are going to use the Unified Extensible Firmware Interface. So the firmware chip that we use today is the UEFI. Anything from 2013 and prior, 2008, 2009, 2010, is going to use the BIOS. And the master boot record is associated with the BIOS. When it comes to the other partition table that's associated with UEFI, that partition table is called the GPT. So the GPT is associated with UEFI. And that GPT it's a long name. It's the globally unique identifier partition table. And we're going to pull this down here. The globally unique identifier partition table. Okay. That's what GPT stands for. So UEFI, arrow, get it here. Another arrow. Get it there. Oh. All right. So going forward, when we talk about firmware chips or your firmware update erases your BIOS or your UEFI and installs new instructions on your BIOS or your UEFI. Okay. That's what your firmware update is. And you'll have operating system updates in that. You may have some chip function updates in that as well. Okay. Now let's pause for a second. I want to get a check for understanding. Okay. What are the 3 filing systems associated with Apple, Mac, and Linux?
APFS,
Correct.
NTFS,
Correct.
and EXT4.
Correct. These are the 3 filing systems. Okay. Your filing systems are used, and it's based upon the operating system. So if you have an Apple operating system, APFS. Yeah, if you have a Windows operating system, NTFS. If you have a Linux operating system, EXT4. Okay. Extended file system 4. Okay. Your hard drive has what we call, when you buy a new hard drive, you have to partition your hard drive and you have to format your hard drive. Okay. Partitioning divides your hard drive into sections, hence the lines going across like a pizza, okay, into different slices. Your formatting will format or draw the lines or grooves that your information is going to be stored in, okay? So that's formatting and partitioning. Your kernel is the root of the operating system. Your kernel provides security. It's there for apps and programs because it controls apps and programs and processes, and it controls hardware and software. So if I ever ask you what's the functions of the kernel, it is to control hardware and software. Now, your kernel sits in a partition in a particular sector of that hard drive. Okay. When we want to have virtualization software, or virtualization, we have to go into the BIOS on the motherboard or the UEFI, and we have to enable virtualization services. But that means that a hypervisor has to be either available or installed on this computer, okay, or hard drive. So your hypervisor is going virtualization software that's going to act just like the kernel and control software or hardware, okay? And it will sit in a particular partition, especially when you load different operating systems. So I could load up Linux onto this hard drive and have Windows on this hard drive as well. And whenever I load Linux, I'm going to need something that will allow me to read the Linux operating system. So I will need virtualization, like a virtualization player, like VMware or Oracle Box or things of that nature, okay, which we will get into later. So if anyone ever asks you what is virtualization, virtualization is the ability. So virtualization, this is in my terms, virtualization. The ability to have more than one operating system on a computer. Okay, that's virtualization. So I can have one computer with 2 operating systems on it, 2 or more. Okay. So that's virtualization in layman's terms. What is virtualization? The ability to have more than one operating system on a computer. Okay. I know it's a lot. Let me see if I can take a snapshot of this. Hmm. All right. Ooh, that looks like gibberish, boys. Say virtualization. All right. So, with that, looks like do we have questions? Operating system. Okay, cool. All right. So now give me a second and I'm gonna come off the screen and I'm gonna show you an example of what when we look at systems, we can see what partitioning looks like. All right, so give me a second. I'm gonna change my share. Continue. All right. Can you see my screen? Okay. So in most cases, when you partition your hard drive, it's going to look similar to this. Okay, so this is a form of partitioning. So now your hard drive is divided, and I'm going to see if I can find a larger image or make it larger. Okay, so when you partition your hard drive, you divide your hard drive into different volumes or what we call sections. As you can see here, this is the system recovery drive or partition. Here you have your C drive, which is a partition. Then you have your new volume that you made, which is another partition, which is your healthy primary partition. You have some free space. And then here you can create what you call another healthy or logical drive. And then they're color coded here. And this utility is called disk management. So this disk management, if I was to right click on my PC and go to disk management, then my partition table information is going to come up. Why is it telling me to initialize disk 7? We'll cancel that. And so this is what my partition looks like. And these are all the different hard drives that I have on my computer. Okay. So you have one drive. This is the UEFI. That's why it says EFI system partition. This is the C drive that has a lot of different files on it. I have another drive in my computer. Yeah, all these drives are connected to my computer. And yes, I use each and every one of them. But this is how when you partition your drive. So you have primary partitions and simple partitions, things of that nature. Once again, if you wanted to find that, you would right click on your computer and go to disk management. And when you get disk management, this is when you're going to see your different partitions on your particular drive. Okay. So I'm gonna ask a question. When I ask a question, we're gonna take a break. And when we take a break, we'll come back and I'll have a video that describes everything I just talked about. Okay. All right. Here is my question. My question is, what is the purpose of the kernel? What is the purpose of the kernel?
It's the root. I'm sorry, I'm looking at my note.
That's fine.
Isn't it the
Root
like
is the source of the
governor?
operating systems.
Say it again.
Root of the source of the operating systems.
Root or the source of the operating system. That is what the kernel is. Now, what does the kernel do? Yes, it controls hardware and software. That's what it does. So make sure you differentiate between the two. What is the root of what is the kernel? It's the root of the operating system, the source of the operating system. Then when it comes to its functions, it controls hardware and software. All right, everybody, it is 6:54. Let us take a 10-minute break. Actually, make it a 15-minute break, and then we'll come back. Okay. All right. recorder back on. And hopefully if you're back, leave a 1 in the chat. Make sure you leave a 1 in the chat room. All right. So let's go ahead. We want to watch this quick video on virtualization, and I love the way that this lady breaks it down. So let's watch that video. Okay.
Hi, my name is Kaylee Bovey with the IBM Cloud team, and today we're going to be talking about virtualization. As you know, virtualization is a fairly old technology, but it's still super relevant to building your cloud computing strategy today. So first off, what is virtualization? Simply put, virtualization is the process of creating a software-based or virtual version of something, whether that be compute, storage, networking, servers, or applications. And what makes virtualization feasible is something called the hypervisor. So we're going to write that here. And what a hypervisor is it's simply a piece of software that runs above the physical server or host. And there are a couple different types of hypervisors out there. And what they do is essentially pull the resources from the physical server and allocate them to your virtual environments. There are 2 main types of hypervisors out there, one being type 1, very simple to remember, and 2, you guessed it, type 2. So let's start with type 1. A type 1 hypervisor is a hypervisor that is installed directly on top of the physical server. They're also called bare metal hypervisors, so we'll write that up here, just so you can remember. These are the most frequently typed of used hypervisors, and they're most secure, they lower the latency, and these are the ones that you'll see in the market the most. Some examples would be VMware ESXi, or Microsoft Hyper-V, or even open source KVM. The other type of hypervisor is a type 2 hypervisor over here. And what makes these different is that there is a layer of host OS that sits between the physical server and the hypervisor. So, by that nature, they are also called hosted. These are a lot less frequent. They're mostly used for end-user virtualization, and you might see some in the market that are called like Oracle VirtualBox or VMware Workstation. Again, they're a lot less frequent. They're a bit more, they have a higher latency than a type 1 hypervisor. So once you have your hypervisor installed, you can build virtual environments or virtual machines, or simply put, VMs. So let's spin up some environments. So what makes a VM a VM? A VM is simply a software-based computer. They run like a physical computer, they have an operating system and applications, and they're completely independent of one another, but you can run multiple of them on a hypervisor. And the hypervisor manages the resources that are allocated to these virtual environments from the physical server. So, because they're independent, you can run different operating systems on different virtual machines. So you could run Windows here, or Linux here, or Unix here, for example. And because they're independent, they're also extremely portable. You can move a virtual machine from one hypervisor to another hypervisor on a completely different machine almost instantaneously, which gives you a lot of flexibility and a lot of portability within your environment. So looking at all of this, this is the core of virtualization as a process. So let's talk about a couple key benefits that you want to take away from this. One, cost savings. When you think about this, and the fact that you can run multiple virtual environments from one piece of infrastructure means that you can drastically reduce your physical infrastructure footprint. This is consolidation at its core, and the fact that you don't have to maintain nearly as many servers, run as much electricity, save on maintenance costs, means that you save on your bottom line at the end of the day. Number 2 would be agility and speed. So like I said, spinning up a virtual machine is relatively easy and quick. A lot more simple than provisioning an entire new environment for your developers if they say they want to spin up a new environment so that they can run a dev test scenario, whatever it might be. Virtualization makes that process a lot simpler and quicker. And 3, lowers your downtime. So let's say that this host goes out unexpectedly. The fact that you can move virtual machines from one hypervisor to another on a different physical server means that you have a great backup plan in place, right? So if this host goes down, you can simply move your VMs very quickly to another hypervisor on a machine that is working. So with this is really virtualization today. And like I said at the beginning, virtualization is a technology that's a few decades old at this point, but it's still super critical to understand for your cloud computing strategy today. Thanks for watching as we discuss the basics of virtualization. Make sure to subscribe below and give us a big thumbs up if you liked this content.
What's up,
Alright.
y'all? I've got a question for you. What are virtual machines and containers, and how do they fit into our modern cloud-native way of building and architecting applications? My name's Nigel, and I'm going to try to answer that question for you in 4 parts. First,
I'll come back to Nigel another time. See, that looks kind of interesting. All right. So if you wanted to know, let's say you're in test out and you wanted to know where to access that information, you can go to the system implementation section. Now I know you said, well, if that's in the 1101, why is it in an 1102 section? You're still going to see some aspects of virtualization in the 1101, especially if you look at the core objectives. Okay. So we're going to look at cloud computing and the different cloud computing facts. And then as you can see, I'm trying to drill this concept home. So it's not that long, but long enough that we need to really just understand it, since virtualization is about 15% of the exam. So if you go back here to your core competencies, or the 1101, excuse me, core objectives. And if I was to access this PDF and scroll here, as you see, virtualization and cloud computing on the first exam is 11%. Mobile devices is about 15%. Okay. So let's take a look at this content here. Sorry. Once again, this is in the system implementation section. If you're looking in your CompTIA manual, I believe I put it in the chat. It is between, pull it back up, pages 487 to 508. 487 to 508 in the CompTIA study guide. All right. So in this section, let's kind of review cloud computing. So now that we've talked about some of the components of virtualization, we've talked about hypervisor, we've talked about the hard drive, we talked about operating systems, we talked about the kernel, we've talked about the BIOS or the UEFI chip. We've also talked about the only thing I didn't mention is that once it finds once the BIOS finds the master boot record or the GPT table, and it finds the kernel, then it takes the kernel and all of its programs and it places it on the RAM. And remember, we talked about grouping. Whenever I talk about processing, immediately your mind should go to the CPU and the RAM. And the RAM is for processing. So when your computer starts up, your operating system has been placed on your RAM. Okay. And now you see the splash screen, you'll see Windows or you'll see Apple. You'll probably hear a ding or a bell or something that just lets you know that now everything's working. So now what we want to do is I'm going to kind of backtrack before I go into cloud computing, because cloud computing is just a data center located somewhere. And here I am in Maryland, the data center's in California, and we're sending messages via the internet or via Wi-Fi radio frequency waves, whether it's cellular or Wi-Fi systems, the messages have to get to that data center. So let's kind of look at the virtualization facts once again. So this will give us the actual terms and terminology. All right. So we're going to learn about the purposes of virtualization, and we're going to also close this. the purposes of virtualization, and we're going to talk about virtualization concepts. So when it comes to virtualization, you have certain benefits that are associated with virtualization. You have sandboxing, and sandboxing is when, just like it sounds, you can take your operating system and lock it down so that none of its resources, or it basically won't use any resources on the computer. Here it says the process of creating an isolated testing environment. Virtualization lets you easily create a sandbox by isolating components from the production network. Now, this is section 6.4.2, virtualization facts. It says the virtualization sandbox, also known as the playground, gives network administrators and developers a safe place to create new software, test software, install new software. So when most of my students say, "Yeah, I want to, like touch the networking devices and do this and do that," no organization will let you do that. Their updates are going to be made in a sandbox environment. Testing is done in a sandbox environment because, as it says right here, you can upgrade existing software without risking the production network. Because when it comes to the CIA, confidentiality, integrity, and availability, you want your organization to remain available. Okay. You have your application virtualization. Okay. The process of installing and accessing applications virtually. This can help reduce license costs, increase accessibility for local and remote employees, and make it easier to install and maintain applications. Okay. Then you have legacy software. Some organizations require the use of proprietary or legacy or outdated software. Some organizations have that one machine that they've had since 1999 and it's still making them money. So you can't update the system, so you need to keep it going. Sometimes the best recourse is to virtualize that device and now use that software inside of a virtualization software where you can run some of those applications. Here it says virtualization can provide access to this software even if the user's local PC is running an updated operating system. Then you have cross-platform virtualization, the process allowing an operating system to access an application designed to run on different operating systems. And then you have hardware optimization. So this is like the processor is optimized to process several tasks. In other words, virtualization is on your computer and it is using the hardware devices of your computer to actually work. So here are the components of a virtualization system. You have your host machine, which is going to be the hard drives, optical drives, RAM, CPU, and the network interface cards. You have hypervisor, a thin layer of software that resides between the virtual operating system and the hardware. This is why I introduced these terms first, so they will start to make more sense. Then you have what is called your virtual machine, a software implementation of a computer that executes programs like a physical machine. The virtual machine appears to be self-contained and autonomous. Your virtual machines are going to be like your VMware, your Oracle box, things of that nature. You have your virtual hard disk. So when you have a virtual operating system, you also have storage space that they refer to as a virtual hard disk. Here it says the operating system is the host operating system that simulates a hard disk for the virtual machine. Then you have a vSwitch or virtual switch, software that facilitates the communication between the virtual machines by checking data packets before moving them to a destination. A switch is a segmentation device. So a switch can be, and I'll show you an image of a switch very quickly. Switch. So this is a network switch. A network switch is like a segmentation device. This is a 48 port switch, so I can connect 48 computers to this particular switch. Let's see. And then what I can do is I can section or segment those computers from each other, especially if they have certain resources or functions that need to be performed. I could take these first 6 ports if I have computers connected to them, and that could be my human resource department. This could be accounts payable. This could be finance. This could be HR. You know, I could divide up the network however I want using this switch, which we refer to as a segmentation device. So if you hear me talk about a switch is a segmentation device. Okay. And we'll get more into that when we dive more into the networking chapter. Just put a pin in that, put that in your notes. Say a switch is a segmentation device. Okay. And this is the ports on the switch. Okay. Then you can have a virtual router. Somebody was going to say something.
I was going to say, at first when I saw that price tag, I was like, wow, but I see why it's that high.
Oh, yeah. It's very important. And believe me, every building, every office, if you see a group of computers, they're going to be managed by this switch. Okay. On each floor of your building. Sometimes multiple rooms are managed by different switches. Yeah. And that's how we segment or divide certain areas. Sometimes we don't want accounts payables to talk to accounting, or we don't want finance to have conversations with accounting. So you'll use that switch to separate those communications.
Gotcha.
Okay. And I'm going to pull up a router. A router connects remote networks. So I'm going to do a network router. Network. Oh, here we go. So here's an industrial router. Come up. So here's a router. What is it? That's a switch. I'm sorry. I saw those ports. I'm like, that's not a. Here we go. Here's a router. Even though those other ones were routers as well, but those are more like home routers. This is more of a professional router. Okay. This is what you'll find in a server room, a TP link. You know. So a router connects remote networks. So say like you have two offices and you want them to communicate between each other. This router, which would be in a server room, would route traffic out of your building into another building. Okay. And that's the purpose of a router, just like your home router. You have your communications that come inside your network and then communications that leave outside of your network. So what a virtualization software will do, virtualization software will create virtual versions of these so that your messages can leave your virtual network and go into your host network, because the host computer has to send everything. Okay. And then you have a virtual firewall software that functions as a network firewall device that provides packet filtering and monitoring. All messages are called packets. Okay. All your messages, just like we call our messages mail in the real world, or we'll say email, all your digital messages are referred to as packets. So when we talk about packet filtering, it's moving the packets through the system. And here it says the virtual firewall can run as a traditional software firewall on a virtual machine. These are the terms and terminology. I want you to get to know them like the back of your hand. Remember, this is 6.4.2. All right. Now we're going to go over, watch the video overview, and then we're going to go over some questions a little later once we go through some more content.
Although some types of computer virtualization have been around since the mid-1960s, it really didn't become accessible to most users and companies until about 1999, when VMware introduced the first x86 virtualization product. Since then, many other companies have developed ways to make virtualization easy to use and affordable. Using virtualization, companies can often reduce operating costs, simplify management tasks, and provide many other benefits. As a PC technician, you'll need to become familiar with these concepts. So in this lesson, we'll give you an overview of what computer virtualization is. To better understand the benefits, let's first review the traditional computing model. Having owned or used a desktop or laptop computer, you're already familiar with this model. You know that your computer runs an operating system like Windows or Linux, and that one of its jobs is to interact with the computer's hardware. For example, the OS takes care of the disks and file system and does other housekeeping tasks. The key idea is that a single operating system has full control over all the hardware resources on your computer. And while you may enjoy the lightning speed, this computing model is inefficient. Unless you're using some hardware-intensive applications, such as a video editor, it's likely that most of your computer's hardware sits idle, even when you're multitasking between several applications. To further illustrate this inefficiency problem, suppose your company has purchased some costly servers. You wouldn't want these servers to sit idly by when they could be doing more computing work, offering more services, or responding to a larger number of users, right? Using virtualization is one way you can improve efficiency, especially on a server. With virtualization, you can pool multiple operating systems on the same physical hardware. Each OS runs independently and runs its own set of applications. These independent operating systems are called virtual machines, or VMs. You'll also hear them called guest operating systems. When you run multiple VMs, the demand for hardware resources increases, resulting in better hardware utilization. You can implement virtualization using special software called a hypervisor. Hypervisors come in two types. This image shows a Type 1 hypervisor, which is often called a native or bare metal hypervisor because it runs directly on the computer's hardware to manage the guest VMs. If you're familiar with Microsoft Hyper-V Server or VMware ESX, it's good to know that both are Type 1 hypervisors. A Type 2 hypervisor is a software application that runs on top of a conventional operating system to manage the guest VMs. When one needs to interact with the host hardware, it must do so through the hypervisor and then through the host operating system. VMware Workstation, Oracle VM VirtualBox, Parallels Desktop for Mac, and the open source QEMU product are Type 2 hypervisors. Some of the advantages of using virtualization is that it can increase IT agility, allow for greater flexibility, deliver increased performance, and let you scale up quickly while enjoying significant cost savings. Now, another type of virtualization is known as virtual desktop infrastructure, or VDI. Similar to what we've just discussed, VDI is used to virtualize desktop computers on a remote host. But with VDI, the VMs are created with the intent of being the end user's main computer system, which can be accessed from something like a tablet or thin client. Since these VMs run remotely, all the processing is done on the host or remote computer. These VM instances are accessed using a connection broker, which is typically a software-based gateway that acts like a traffic cop to control session access between the end user and the VDI. With virtual desktop infrastructure, you have the option to implement it on-premises or in the cloud. VDI on-premises means that your company is responsible for the purchasing, installation, and maintenance of all the hardware and software. This can result in very high upfront costs, but savings over time. VDI in the cloud means that a cloud service provider owns the hardware and hosts all your data and applications. Then your users can access the required desktops online. In most cases, a company is billed monthly for these servers, which could add up over time. Another category of virtualization that has gained popularity recently is container virtualization. You may have noticed that each virtual machine requires a guest operating system. This requirement keeps each VM isolated and prevents interaction between applications running on different virtual machines. These multiple operating systems not only introduce computational overhead, but also require you to purchase additional licenses. A better solution is container virtualization. Containers are defined as consistent runtime environments. You create these containers using special software called a container engine. On each one, you install an application and its dependencies, including libraries, other binaries, and configuration files that are required to run the app. The benefit is that the application is isolated from others running within different containers. This is good for security and portability. You can save a container and easily port it to other environments as well. If you compare containers with virtual machines, you'll see that each has its benefits and shortcomings. First, containers are more lightweight and use fewer resources than VMs. Virtual machines are portable between different hypervisors, whereas containers are only portable between different families of operating systems. Generally, you can save a virtual machine running in one hypervisor environment and run it in another hypervisor environment, even if the two are from different software vendors. Conversely, an application that's containerized in a Windows environment can't be run by a Linux container engine. A container might only occupy a few megabytes, whereas a virtual machine might take up several gigabytes. That means a single server can host many more containers than virtual machines. Also, a virtual machine may take several minutes to boot, while a containerized application only takes a few seconds to initialize. It's common for a container to be instantiated at the last second and then removed when it's no longer needed. Containers also make it easy to modularize applications. You can create containers with simple applications that are built into a larger system. Then you can change one application without rebuilding the entire system. As you've seen, virtual machines and containers use their host for processing, so it's important that the physical hardware is secure. If an attacker were to obtain access to a piece of hardware that houses numerous VMs or containers, they could potentially control or adversely affect all of them. It's also important that you develop procedures for creating and managing your virtual systems. Security procedures for virtual systems should be like those used for physical systems. In fact, it could be argued that security for VMs is even more important because VMs are created for easy replication. One bad configuration could be replicated across your network. Virtual machines and virtual networks should be documented and should be included in the same network maps as the physical.
All right. So as you see, I'm really trying to drill this home by reiterating a lot of those concepts: sandbox virtualization, application virtualization, legacy software, the uses of legacy software. Think of it, I have a trucking company, but I'm still using Windows 7. If I may have to use virtualization so that I can still protect that software and use some of my programs and applications on a newer computer, but still running the older software. So please get to know this terminology. Okay. Let's now, we've been talking about the actual VMware tool or the virtual machine. Now, when we're talking about virtual machines like VMware, Oracle Box, this video is going to get into those concepts and how those things are looked at. So what I'm really trying to do is drive the concepts home. So let me ask some questions. Okay. Here's question number one. What is the kernel?
The kernel is like the primary source of connection, like it helps everything run
Okay.
and stuff.
Okay. Anybody
Is that
else?
it?
The root of the operating system.
Yes, the root of the operating system. Absolutely. Now, what are the functions of the kernel?
The hardware and the software.
Yes, it controls hardware and software. Okay. Um, in order for me to have virtualization, what do I need to add to the kernel?
The hypervision.
Okay, a hypervisor.
I
Absolutely.
mean, visor.
No, you're fine. You're good. I knew what you were saying. A hypervisor. Cool. Good. All right. On the hard drive, name me the type of um, term that we talked about where we would find our kernel. There's two terms you could use. Ryan is
It's
correct. Oh, go ahead.
oh.
What you were going to say? Go ahead.
I was gonna say that it sits in a sector of a partition.
Absolutely. So Ryan and who said that? Was that Taylor?
Taylor, yes.
All right. So it sits in a sector of a partition. Absolutely correct. Okay. Good. So with that being understood, now that we understand that, and that you have different types of virtual environments. Now let's kind of look at the tools that you would use to actually interface with the soft. Like once I install everything on my hard drive and I enable it in the BIOS of the UEFI, now how will I be able to use it? I need to have some type of virtual machine that's going to run the operating system. Okay. And we call those, in this case, a VMware player. They're different kinds. You have Oracle Box, you have VMware, you have a number of different players. But let's watch this video on this particular player here.
In this demo, we'll be working with VMware Workstation Player, which is a software that allows the installation of virtual machines or VMs. This software is similar to commercially available hypervisors, but on a much smaller scale. VMware Workstation Player is designed to be used on your desktop for either personal or business use. Today, we'll just be looking at the standard edition that you'd use in a home lab or for testing. Let's go ahead and walk through a virtual machine installation. We have several options off to the right. Create a new virtual machine. We'll start the wizard to add a virtual machine to our player. Open a virtual machine. We'll add a virtual machine that was already created elsewhere or with an open virtual machine format, such as an OVF file. There's an upgrade option here to get Workstation Pro, which gives you more features than would typically come with VMware's ESXi hypervisor, but this requires a paid license. You can also get help if you're feeling stumped and want to check out more information. We're going to go ahead and create a new VM. Typically, operating systems have an ISO that's downloadable from their website. We have some ISOs already downloaded, so we're just going to click Browse.
Now, an ISO is a system image. So you can have ones that you can download, and what we used to do is we used to take our CDs and DVDs, and you would store a system image. Basically, you can record what the operating system looks like, and then you could reinstall that onto your hard drive. Sometimes we do that on a flash drive. So an ISO image just gives us a faster way to install an operating system onto a hard drive.
Browse. We'll select our Win11 ISO file and click Open. From here, we just need to click Next. Quickly make sure that the guest operating system is set appropriately. In our case, it'll be Microsoft Windows, and the version will be Windows 10 and later x64. Click Next. Here it gives you an option to name the VM and its location. Just to make things easier, I'll change the name to Windows 11 and leave the location alone. Click Next. Okay, this is one feature that's sort of unique. We have the ability to store the VM's disk as a single file or break it up into smaller files. It says that it might be easier to move the smaller files, but in our case, we just want to keep it as one. Also be mindful of how much disk space you have on your workstation and how much you plan to use in the future on this virtual machine. There are usually bare-bone requirements for all operating systems. Of course, you may want to add more if there's another purpose to this VM. Let's click Next. Notice that it didn't give me the option to tweak more VM settings. If you do want to fine-tune things more, like adding more CPU or memory, tweaking the network, etc., you can customize the hardware here, or do it after the fact by right-clicking on the VM and going to Settings. Click Finish. Now we have a newly created VM ready to boot. Let's go over the settings that we have. Some of this is self-explanatory, like adding or removing memory, processors, or even hard disk space. The network adapter is where it gets interesting. There are many types of network connections to choose from. Bridged connects directly to the physical network card. NAT shares the host's IP address. Hosts only puts the VM in an isolated private network. Custom drops it in a virtual network, and LAN segment does something similar. NAT may be your best choice if your VM just needs to reach the internet and isn't going to be used in conjunction with other VMs. If you want to network several VMs together, you can use a custom virtual network or LAN segment. For example, if I wanted to create a firewall VM that all my VMs go through first before they hit the internet, I might have two network adapters in here. One of them would be the NAT, the internet source, while the secondary one would be the LAN, or a custom virtual network of my choosing. Then all the other VMs would use the virtual network and not the NAT connection. In our demo, we're just going to leave it on NAT and click OK. Now it's time to power this on. Clicking Play Virtual Machine makes it come alive. And just like that, we're booting the Windows 11 ISO to start the installation process. Keep in mind that you have to leave the player open to run these VMs. These aren't meant to run what they call headless and in the background with VMware Workstation Player. Once this application is closed out, your VMs close out as well. That's it for this demo on virtual machines. In this demo, we discovered VMware Workstation Player. We also showed you how to install a VM and tweak its settings.
All right. So now we've been talking about this. It is so easy to take your computer, if you have one, and make it a virtualized computer. So let's say you wanted Linux. You wanted one of the best forms of Linux. Kali Linux. I might have already downloaded it. So I've had it on there, but I had viruses, teaching sometimes and using my personal computer and teaching. I've caught like 3 viruses over 3 years. So I had to reinstall the operating system. And, I had it set up real sweet one time. Especially I did an interview with it. But if you wanted Kali Linux, all you got to do is go to the Kali Linux website, and then you can download a version of Kali Linux. Just that simple. You can have it on your computer. All right. Then, in order to really use that, you would need to download what we call the virtual player or the virtual machine. So you can have VMware. You can go to their particular website, VMware, or you can use Oracle Box. So you can use the virtual Oracle Box. But in most cases, I typically, and I'll tell you how I really got into this is because I was teaching Linux for the Community College of Baltimore County. And then as I was teaching that, I had to, kind of learn it as I was teaching it. And at the same time, they set me up with a version of Linux, and I had to install it on my computer. So this is kind of, how I kind of learned. So, but I typically use VMware. It's easier. You have a workstation player. You can go here, and depending on your operating system, so you can download it. And here you can download this. This is free software, and it's still on Workstation Player 16. So this player or this VMware is going to read your operating system once you download it. So and then you'll load them up at the same time. Okay. So doing virtualization is easy, and and work through the process of understand. I often tell people, if you want to advance, you have to experiment. You have to like test the borders and see the things that you can do, but just some things you got to be careful with. But one of the best things you can do is download a virtual machine and then learn how to use Linux and other tools that are associated with that as well. Okay. So just showing you how to do that and just adding that information. And some of this I did learn on YouTube as well. There's a guy, he's great. It's called Hackersploit. As you see, they won't let homeboy live. And that's my guy right there. I might jump on his live. So Hackersploit, look at that. He's not letting Jay. I don't know why, my man. You have to apologize. What kind of freaking apology? Anyway, Hackersploit, great website. Okay. Hackersploit, especially if you want to get into cybersecurity, you want to get into pen testing and things of that nature, and learning how to. This website is amazing. I mean, this YouTube channel is amazing. And you can like just peruse and just watch. It'll teach you how to use Linux and things of that nature. As you can see, ethical hacking, penetration testing, complete courses. They get to the point where they offer their own courses, but this is as you go a little more advanced. I'm about to start doing that myself. But anyway,
Hey, Professor Howard, all right,
yes.
this may take you off course, a little bit. And if
No.
it does, then I can wait till later on. But
No, go ahead.
so I have to use like Kubernetes and Docker at work. What's the difference? Is the difference between virtual machines and containers just VMs more so deal with the operating system and containers are more applications specific?
Uh, Yes. So containers would, to me, my understanding of containers is going to be on the system. So the system will be its own VM. Okay. When you're using VM, well, I hate when I use a term to define a term. When you're using virtual machines, you're using host and software based technology. So what I just explained to you is a VM technology. If the device already comes with the VM on it and you don't need the host software, then that's a type 1. Okay. And that type 1 is different. That's a container. Okay.
Okay.
Yeah. So the typically when she said it wasn't used a lot, the other lady, it's used more in home environments. It's used more in teaching environments or individuals who install VMware, but more corporate organizations are going to use containers.
Okay.
Yeah. Okay. So that was the VM player. And like I told you, there's more than one. There's plenty of different virtual players out there, or what we call virtual machines. Thank you. Appreciate it. Can you take these back? Wait. You're gonna leave that. Thank you. Hey, all right. Good. So getting back to this. So let's look at Hyper-V. All right. So Hyper-V, the software that we use to um, install our virtual machine. This is what we're going to look at right here. The use of Hyper-V. Okay. 5 minutes ain't bad.
Hyper-V is virtualization software created by Microsoft in 2016 that lets you run other software like it's on a physical computer. We call this a virtual machine, or VM. With a VM, you're able to have many different operating systems installed on one physical system. Today, we're going to look at how to enable Hyper-V on a desktop. In the Start menu, look for the Features keyword, and it'll direct you to the section to add or remove features. Alternatively, you could go to Control Panel, Programs, turn Windows features on or off. This is the area that controls extra features that come with Windows, ones that might not be enabled by default. Also, before we go on, it's important to know that you won't be able to enable Hyper-V unless you have the Pro version of Windows. Now, after clicking OK, it'll process your request when it's done and require a reboot. We're going to do that now, so I'll pause the recording. Okay, our reboot is complete, and we're ready to launch Hyper-V. To do so, we go to Search and type Hyper-V. This brings us the Hyper-V Manager. Eventually, when you have VMs, they'll be populated over here. This manager allows you to control all the local Hyper-V instances along with remote ones. We're only worried about our local one, so we're going to right-click here and select Virtual Switch Manager. Here's where we manage the virtual switches that will be used for the VMs. It's a good idea to configure these first so you know how your network is going to be set up. And there are 3 options to select from here. External binds to the physical network adapter. This would give a VM access to the internet and the physical network that your PC is connected to. The internal switch is similar except that it doesn't allow direct access to the internet. This would be a good option if you had several VMs that needed to talk to each other without access to a physical network. Private is completely isolated. Some use cases for this would be restoring a VM for testing purposes that you don't want to communicate with anything. We're going to do something simple and select Internal. Let's give it a name of Internal as well. Would have the ability to select the Ethernet controller or Wi-Fi adapter if we'd used the external network switch. If there were other network adapters available, they'd be listed here too. And if you were running VLANs, you could select this and tag the network with a certain VLAN ID. Click Apply when you're done creating your switch. One thing to notice here is the default switch. This switch does use the internal network setting, but the part at the bottom makes it different from the internal network we just created. This has NAT, or Network Address Translation, set up to give your VMs access to the computer's physical network. If the NAT weren't on, you wouldn't have access to the physical network. This default is set this way to make it easy for users to start right out of the box. Anyway, click OK. Now we're ready to create our first VM. Right-click on the host and select Quick Create. In here, we select the ISO of our choosing from some default options. Or we could just upload our own from a local source. I happen to have one in my Downloads folder, so I'm going to go search and grab my Windows ISO. After selecting Open, we're able to go through and create our virtual machine. Before booting, we need to check out some settings first. They make it handy by giving us the ability to launch the settings from here. In here are all the settings related to the VM we just created. We're able to tweak quite a few aspects like memory, processor, hard drive, and more. Let's adjust some of these. Our memory is a little low. For default specs of Windows, we can up it to 4096. It does have the ability to dynamically change as well. Under processor, it's set to 8. Let's adjust it to 2. Under network adapter, we need to configure this VM to use the network we created. For our case, we need to use the isolated network. However, it's possible to create a firewall VM with 2 network adapters, one being connected to the physical network and the second one to the internal network we just created. Essentially, that gives you total control of what comes in and out of your Hyper-V host VM. Lastly, let's give this a name. This could be a convention or something of your choosing. Apply and click OK. Connect allows us to start the process to power on the VM. This is essentially the VM's console, just like you'd see from a computer booting up from a monitor. Click Start, and just like that, we've started the process to install Windows. And that's it for this demo. In this demo, we went over how to install Hyper-V. We also configured a new virtual switch and created a VM.
All right. So let's go over some facts. And then what we can do is I'll let y'all go for 10 minutes. And then we'll come back to this. You know what? It's 8. Go ahead and take your 15-minute break. We'll come back at 8:15. All right, everybody. 8:17. I am back. Let's see. Let's briefly talk about the facts associated with Hyper-V. Okay. Um, so as we stated earlier, there are two types of Hyper-V or hypervisors. Type 1 called bare metals, which we associated with the container. It says acts as an operating system on a physical host. Okay, the type 1. The type 2 acts as a software application, and it is run on any operating system and can run several operating systems on virtual machines. Capacity is limited by available physical assets. So you have your type 1 and type 2. Your number of VMs supported.
Do you
It
have your
says the
screen
number of
up?
Hello?
Do you have your screen up? Like the mod?
Oh, thank you so much. I just jumped right in, staring at my screen. Ugh. See, gotta get that out of the way. Thank you for that. Okay. So this is 6.4.5, where we're going over the content on the talked about the two different types of hypervisors. You have type 1, which is called a bare metal, where it acts as an operating system on a physical host. In other words, that would be the container operating system. Then you have your type 2, acts as a software application, is run on any OS and can run several operating systems on virtual machines. Capacity is limited, and those will be your VMs. The number of VMs supported, and it says the host accommodation, or it depends on the components installed on the host machine and what has already been allocated by the Hyper-V manager. So these are some things to just think about. Since close to all or 80% of all VMs are over provisioned, this means they have more resources allocated to them that is needed. So when we're talking about provisioning, we're talking about the allocation of resources. This decreases the efficacy of the physical host because now you have more things running on that host or more resources are being used. When provisioning, consider CPU and RAM allocations. So remember earlier I said if you're going to use virtualization, you have to have a strong CPU and a lot of RAM. Storage space can easily increase, but it's almost impossible to decrease without destroying the VM. So you have to have a lot of storage as well. So your CPU, your RAM, and your storage, you have to have a lot of that. And here, system resources, we're talking about the CPU, the storage, and the RAM, or the provisioning that's taking place. Your hypervisor manager accesses those resources. And then these are the different types of options. You have Hyper-V, you have VMware Workstation, you have VirtualBox, which is by the company called Oracle. And even gives you a step on how to enable Hyper-V in um, Windows 11. So you access your control panel, select programs. Under programs and features, select turn Windows features on and off or off. Expand Hyper-V. Place check marks by Hyper-V management tools and Hyper-V platform, as they did here. And then it says if Hyper-V platform is grayed out, virtualization support has been disabled in the firmware, what we call the BIOS. It says refer to your BIOS firmware documentations for instructions to enable. Now, my question to you is what is another term that we use for BIOS? Basic input output.
The UV.
The U. Say that again.
UFI. Is that how you pronounce it? UEFI.
Yeah, the UEFI. Yep. Unified Extensible Firmware Interface. Yep, that's correct. Then select OK, and the system will reboot. You can configure virtual networking. What does that mean? It says you can choose the type of network you want to set up, external, internal, or private, like he did in the video. You can use virtual switches or virtual switch manager to select your network interface card. That's, I would have to switch screens to show that. You can create a virtual machine, run Hyper-V Manager, and specify the following parameters. Create a name for your virtual machine, the virtual machine generation. It's walking you through the steps in the process of the different things that you can do. And remember, if you have a virtual machine, you also have your virtual hard drive as well. It's a file that you can use. And then you can start your virtual machine, or you can move the virtual machine as well. I'll give you the options to read through that a little later for the sake of time. I'll move on. We have a lab where we can create a virtual machine. Um, that's something that maybe we can do. Well, I'll schedule that probably on the beginning of Wednesday, that we can walk through that as a group and we can create this. Give us about 30 minutes, 30 to 45 minutes to work on this lab together. And we can do that. Don't let me forget either that I said we can do this lab together for about 30, 45. It's not going to take that long, but as a group, I want to make sure that we all are able to go through just so you'll get more understanding of the virtual machines and things of that nature. So we can do that next time. And as you can see, there's 2 labs. So we'll take about 45 minutes and work on that. So let's go over some of the questions so that we can, just get a feel for virtualization and an understanding for virtualization. All right. So you have this question right here. And this question here says, match each virtualization component on the left with the appropriate description on the right. Each type of component may be used once, more than once, or not at all. So we have host machine, hypervisor, virtual machine, virtual hard disk drive. Provides the hardware necessary to create a virtual environment.
Host machine.
A thin layer of software that resides between the virtual machine and hardware.
Is it the hypervisor?
Mhm. A software implementation of a computer. A software implementation of a computer.
Virtual machine?
Ah. A file created to store data.
The hard disk?
The hard disk.
Mhm. Allows virtual machines to interact with hardware.
Host.
The hypervisor.
Allows host machines to interact with hardware. Let's see if we're right. Booyah. All of them are right. All right. Good, 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 good. Let's go to our next question. Any questions before we move on? All right, good. So that was just about terminology. Can I get someone to read this question?
I'll read it.
Oh, go ahead.
Oh, go ahead.
No, you can go ahead, Asia.
Okay. Um, you have been tasked with creating a new software application and test the development of the software. You want an environment that can be isolated from the production network for the development of testing. I'm sorry, for the development and testing. Um, what virtualization features will best meet your application development requirements?
Very good.
Sandbox virtualization, application virtualization, hardware optimization, cross-platform virtualization.
Sandbox virtual.
Sandbox.
That's what I was gonna say.
All right. Sandbox. It's good. Sandbox it is. So we're going to go over all these terms just so we'll get an understanding of each one. Sandbox virtualization, the process of creating an isolated testing environment, as they called a playbox. Virtualization lets you easily create a sandbox by isolating components from the production network. Using a virtualized sandbox, also known as a playbox sometimes, gives you a safe place to create new software, test software development, install new software, or upgrade existing software without risking the production network. Then you have application virtualization, the process of installing and accessing applications virtually to help reduce licensing costs, increase accessibility for local and remote employees, and making it easier to install and maintain applications. Then you have cross-platform virtualization, process allowing an operating system to access an application designed to run on a different operating system. So, an example of that is if I have old technology and I want to be able to use the software and that technology and protect it, I can put that software through virtualization into another device. Okay. So cross-platform virtualization, process of allowing an operating system to access an application designed to run on a different operating system. Hardware optimization is the process of making the most efficient use of physical hardware. For example, instead of being idle, the processor is optimized to process several tasks at a time. Okay, good. What is another name for virtual machines?
I'm
Yes,
gonna go with
operating system.
We all agree?
I don't know.
Do you agree? Put a 1 in the chat. We're going with it. Who y'all? He's absolutely correct. With virtualization, you can pool multiple operating systems on the same physical hardware. So, in other words, you can have multiple operating systems on one hardware, the virtual machine. Each operating system runs independently and runs its own set of applications. These independent operating systems are called virtual machines or VMs. You also hear them called guest operating systems. What is a host machine? The hardware necessary to run a virtualized environment. Hypervisor, the layer of software that resides between the virtual machine and hardware. And a sandbox is the benefit of using virtual machines to run tests without impacting the production environment. Next. Can I get a reader for this one?
I'll read it.
Thank you.
You want to create a virtual machine environment in which you can develop and test new software. Which virtualization benefit best describes the testing environment that you want to implement? Hardware virtualization, cross-platform virtualization, sandbox, hypervision. How you say that?
Hypervisor.
Hypervisor.
Mhm. All right, everybody. Create a virtual machine environment.
Sandbox.
Sandbox. All right, sandbox is correct. All right, because you want to control it. You want to keep it in a certain environment where it can't get out. You want to create a virtualized environment that runs directly on the host machine's hardware to manage the virtual machines. Which of the following virtualization types should you use? You want it to run directly on the host machine.
Is it type 1?
Type 1 is correct. All right, so now we'll get a better definition of container. All right, so type 1 is a hypervisor. A hypervisor is a virtualization component that allows virtual machines to interact with hardware on the host machine. Type 1 directly runs on the host machine's hardware to manage guest VMs. Type 2 runs on an operating system to manage guest VMs and does not run directly on the host machine's hardware. A VDI, or virtual desktop infrastructure, is designed to be the end user's main computer system, which can be accessed from something like a tablet or a thin client. You say, what is a thin client? A thin client computer doesn't have a storage device in it. It just thinks. Okay, that's a thin client. And I'll show images of thin client computers. And so in some cases, Xboxes and things like that, they look like thin client computers, but they're not. In addition, a VDI can be hosted by a cloud service provider. A VDI does not run directly on the host machine's hardware. And as we go along, the terms will start making more sense. Container virtualization is focused on providing a virtual environment for a single application and requires a host machine's operation system to run. Container, single application. VDI infrastructure, main computer system, can be accessed from a tablet or thin client. Next question. As a network engineer for a large financial institution, you've been given the responsibility to provide a new financial desktop to the financial advisors in all company branch offices. The requirements for the software desktop include it must be virtualization software. It must be hosted in a cloud by a third party, and it must run on a tablet. Ryan already hit it up. He said VDI. And VDI is correct. Virtual desktop infrastructure is designed to be the end user's main computer system, which can be accessed from something like a tablet or a thin client. In addition, a VDI can be hosted by a cloud service provider. All right. So these questions are geared to help you gain understanding of the concepts. While creating a virtual machine, you decide to set it up to use an external network. What else do you need to do to enable the external network configuration? Think about network. Network interface card using a virtual switch manager. All right. Now that was like using context clues. Someone else said configure the virtual machine to use remote desktop protocol. Says when creating a virtual machine, you decide to set it up to use an external network. What else do you need to enable the external network configurations? So Andre, why'd you say configure the virtual machine to use remote desktop protocol?
My mistake.
No, I just, what if you're right? Now, remote desktop protocol is what technicians use to gain access into your computer. Say, like you say, I can't connect to a computer, or I can't do this, or I have a technical issue. The technician would tell you to download a piece of software to your computer, an application. You enter in all the information he tells you to enter. There's a code. Next thing you know, the technician is now on your computer as if they're sitting in front of the computer. That's remote desktop protocol, is what you can use to fix a computer from a remote site. Very dangerous in hacking. So when you're not using, it should be shut off. This is port 3389. 3389 are the numbers that are associated with remote desktop protocol. Let's see if they give it just says they're not requirements. All right, let's go to question 8. Which of the following accurately describes a hypervisor? Select 2. A layer of software that resides between the virtual operating system and the hardware, allocates the storage space for a virtual machine, allows virtual machines to interact directly with the hardware, controls the number of virtual machines a host can accommodate, manages access to software programs on the host.
The
I
first
feel
one
like
is
first one oh, go ahead. I'm sorry.
No. Y'all good.
First one definitely. I'm trying to figure out the second one. I think it was the last one, but I'm not sure.
Yeah, I would say it's the last one.
We got a consensus. We got two. Everybody agree with that? If you agree with that, put a yes in the chat. Three yeses. Brian says, and three allows virtual machines to interact directly with the hardware. You're outnumbered, Brian. That don't mean that you're wrong, though. And he was right. C allows virtual machines to interact directly with the hardware. Think about this. Manages access to software programs on the host. Now, necessary. So what a virtual machine does is software that controls hardware. So your hypervisor acts like the kernel. Okay. So while it controls, hey professor, I'm lost. Well, just want to let you know I'm here. Oh no, that's hey, it takes a while. It takes a while. Don't even I'm sorry, I read that out loud. My apologies. Um, don't feel bad. Um, a hypervisor is a thin layer of software that resides between the virtual operating system and the hardware. A hypervisor allows virtual. Asia, I got the best analogy and it just clicked. Hypervisor is a parasite. Virtualization is a parasite. So when a parasite enters the body, and you heard of that parasite that takes over mice, and it's really in the brain of the mice, and it's the only thing keeping the mouse alive. So those like real belligerent mice and rodents, they're trying to get the cat. The parasite really wants to be inside the cat. So what the parasite does, the parasite controls the cat, I mean the mouse or the rat, so that the cat will eat it. And when the cat eats it, the parasite goes in the cat. When I found that, I was like, whoa, that's crazy. Think of that more like virtualization. Okay. Either you can go on an organ and hide there, or you can control the body. Like artificial intelligence. No, I'm not going there. Let me stop. All right. Okay. Which of the following factors significantly determines the number of virtual machines that a host can accommodate? In other words, what factor will associate how many virtual machines you can have on a device? Select two. The components installed on the host machine, the VDE file you want to, VHD file you want to use, what has been allocated by Hyper-V, the Hyper-V manager, installation of integrated services, IS, on the virtual machine, or the number of software applications installed on the host machine. Oh, that sounds logical, Brian. Absolutely correct. Right here, the components installed on the host machine is the provisioning. So the resources you have, your CPU, your RAM, and your storage, the components installed on on the host machine. And then what has been allocated by the hypervisor, what amount of space you've allowed for the hypervisor. So here it says the number of virtual machines on a host can accommodate depends on the components installed on the host machine and what has already been allocated by the hypervisor. Good. Here it says the number of software applications installed on the host machine, the VHD file you want to use, and the installation of IS have little or no impact on determining the number of virtual machines a host can accommodate. Last question. What are the benefits of installing integrated services or IS on a Hyper-V Windows virtual machine? Select 2. Your responses are dramatically improves performance by installing Hyper-V aware drivers, lets you cut and paste between the virtual machine and host, lets you select the network interface card if you have configured an external virtual network, lets you increase the amount of RAM used by the virtual machine, makes it possible to decrease the virtual machine storage space. So it says B. Two people. Another person says 4. Let's increase the amount of RAM used by the virtual machine. Let's see if y'all are right. Boom. Dramatically improves performance by installing Hyper-V aware drivers. So, integrated services improves performance by installing drivers. What are drivers? What are drivers? Drivers are a software that controls hardware. What do I mean by that? If you buy a keyboard and you install it on your computer is going to go surf the internet to look for the software drivers or the instructions for the computer to control that hardware device. Give me 1 second while I do this. I want to right click and go to Device Manager. Device Manager has a list of all of your computer drivers. Okay. These are the different drivers on my computer or the software that is used to control hardware. So that's what a driver is. Yeah, I know it sounds like an operating system, but no. The operating system needs the driver to control hardware. Okay. So if I have a printer, they always tell you to download your print drivers first and then install your printer. So a driver is software that's used to control hardware. Okay. Score the assessment. Everybody, I'll be making this practice exam available for everybody. And you did 2 wrong. You got an 80. I think you passed. No, 80 is a passing score. All right. So I want y'all to go back over that, study that. I'll make that available for everyone. System tools, we're not doing that. I know it's 8:46, but now that we've talked about virtualization leads us into cloud computing. So I don't understand why they did cloud before virtualization, because you need virtualization in order to have cloud systems. Okay? So let's backtrack. Let's backtrack a bit. Go back into system implementation, and we're going to go into cloud computing. Now, the objective for cloud computing is as follows, and we'll go over those terms in a minute. How will we look at so what I'll do with the recording is I will cut it up, edit it, and I will put it online. I thought the driver was used to convert the language from the computer to the printer like PostScript. Well, I try to use layman's terms in order to understand the point of drivers. Um, like if we look up driver hardware, I have to be careful because it'll take me to golfing. Hardware driver. I did that one time and went to golfing. So a driver provides a software interface to hardware devices, enabling operating system and other computer programs to access hardware functions. They never put the whole definition there. I know it's Wikipedia, but still, it's on point. Um, it operates and controls a particular type of device that is attached to a computer or automaton. A device, a driver provides software interface to hardware devices, enabling operating systems and other computer programs to access hardware functions without needing to know precise details about the hardware being used. I don't want to go too deep into that because that can be very deep. What do hardware drivers do? Tell a piece of hardware how to function by communicating with the computer's operating system. So the operating system wants to take control of the hard drive. Remember, we said that the operating system controls hardware. So that's the point of a driver. No problem. All right. So we're going to look at the following terms: summarize computing concepts. We're going to look at the types of clouds or cloud models. What's a private cloud, a public cloud, a hybrid cloud, a community cloud? And then this is what typically confuses people. What is we call infrastructure as a service, or IaaS? What is software as a service, or SaaS? And what is platform as a service, PaaS? And then we'll talk about the difference between shared resources, meter utilization, rapid elasticity, high availability, and file synchronization, which are some of the characteristics of functions of clouds. All right, so let's go over these terms. What is cloud computing? A combination of software, data access, computation, and storage services provided to clients through the internet. So now everything is using cloud computing now, and we're just accessing their resources. You have Amazon Web Services. You have Microsoft, what is that? Microsoft Azure. You have, like some of the like with Facebook and Instagram. We use their servers and their resources, but they're really cloud services. Okay, what is a public cloud? Google Drive, yes. So Google offers a lot of services that are cloud-based services. Say a public cloud, a cloud that can be accessed by anyone. Public cloud-based computing resources such as platforms, application, and storage, these are the resources, are made available to the general public by a cloud service provider, such as Google, which provides many public accessible clouds, and such as Gmail and Google Docs. Okay. And then, you have Facebook, you have Instagram, you have YouTube. We're using these public clouds. Okay. Private clouds, a cloud that provides resources to a single organization. Private clouds can be hosted internally, but because of the expense and the expertise required to do so, they are typically hosted externally by a third party. Okay. Our private clouds are going to be more like our banking institutions, companies, things of that nature, where we access information on their network. Community clouds. Community clouds are going to be like the library, a cloud designed to be shared by several organizations. Access is granted only to the users within the organization who are sharing the community cloud infrastructure. Hybrid clouds, more like the government, even though the government is a cross between private. You know, some services are public, some services are private. a cloud that is a combination of public, private, and community cloud resources from different service providers. Now, some people will say that's more like the library system, but the goal behind the hybrid cloud is to expand the functionality of a given cloud service by integrating it with other cloud services. Please get to know what is a cloud or what is cloud computing and what are the 4 different types of clouds: public, private, community, and hybrid. I used to hate when the exam would ask these questions. Definitely. Somebody was going to say something? All right. So now let's talk about these 3 things here, and then I'll show a video. So infrastructure as a service, IaaS, a service that delivers infrastructure to the client, such as processing, storage, network, and virtual environments. The client deploys and runs software without purchasing servers, data center space, or network equipment. We'll go over examples of that later. Platform as a service, or PaaS, a service that delivers everything a developer needs to build an application. So this is more like a development service. The development comes without the cost and complexity of buying and managing the underlying hardware or software layers. We can look at GitHub like this, because you can do some app development on GitHub, and you can also do a little bit of learning on GitHub as well. Software as a service that delivers software applications to the client either over the internet or on a local area server. So we will look at like Microsoft 360 like this, okay, which will be software as a service. So let's take a quick look at IaaS examples. Let's see. All right. So here it says Amazon Web Services, Microsoft Azure, Dropbox, because you really don't have to buy it, but you can use it. You can use it. Slack, I use that with an organ, and Salesforce. I use that with a company before as well. MailChimp, if you do any online marketing and you're trying to gain emails and things of that nature, MailChimp is one of the best where you can develop your customer base and select emails. But these are IaaS, infrastructure as they've already built the infrastructure. All you have to do is come and use their resources. So it's like you going to a company, walking in the door and using all their resources. All right. So let's look at examples of PaaS, or platform as a service. All right. Now, this is more associated with developing or development. Here you have Google App Genie, Apache Stratos, Microsoft Azure, AWS Elastic Beanstalk. There's just a number of different IBM Smart Cloud. These companies give you the ability to, here it says, these include computing, storage, databases, developer and management tools, and security. Okay. So is Netflix a PaaS? Yes, Netflix is considered a software as a service company because it meets all the criteria of a SaaS. It is a cloud-based service, meaning that users can access it from anywhere with an internet connection. And then we'll do software as a service. And as you see, some of the companies overlap. You said Tubi. Yeah. SaaS examples: Dropbox, Google Workspace, Salesforce. So they offer their software as a service. Okay. Let's take a quick look here. Boom. All right, let me go back. Questions here. All right. So this is going to just be more visual, and that's why I'm going to show this video. 12 minutes. Good googly goo.
Let's spend a few minutes talking about cloud computing. In this lesson, we're going to provide a generic overview of what cloud computing is and some of the forms it takes. The cloud is a set of hardware, networks, storage devices, services, and interfaces that enable the delivery of computing as a service. The cloud part of cloud computing means that a cloud service provides everything you need to perform some computing tasks, whether you need CPU cycles, a complete computing infrastructure, applications, defined business processes, or collaboration solutions. And one of the biggest benefits is that you have access to these services wherever and whenever you want. Let's take a look at how it works. The term cloud means that you're receiving these services from a location that is not local. The cloud you see here is composed of things like computing hardware and networks. It includes storage devices and a network controller which communicates with these devices to gather the information about the network. It includes services like applications and interfaces that allow you to connect to these services using the network and a local device. Cloud services include the delivery of software. In other words, you can run an application from the cloud. It provides infrastructure for an entire computing system if needed. It may provide storage that you can use. The key thing to remember is that the cloud is separate from the local devices. This is a powerful concept. In the past, let's say we needed to run a word processing application. We needed to use that to complete our day-to-day work. Well, how did we do that? We installed the application on our desktop system at work, and we did whatever it is we needed to do. But what happens if we went home for the night, got a call, and someone said, "I've got to have this report done by midnight tonight or you're out of a job. Fix it, buddy." Well, what did you have to do then? You had to go back to work to use the computer. Or you had to use some kind of VPN connection to get back into your computer. Why? Because that's where the application you needed to do your work was installed. Your only other option was to install a second copy locally at home. But that's really inefficient because most of the time you're going to use the copy at work, and very rarely will you use the copy at home. So you paid for two pieces of software. One you will only use on rare occasions unless you are dishonest and installed the same copy twice, which you shouldn't do because it's against the law. Likewise, if you were in the office one day and just decided, you know what, I'm sick of being in my cubicle. I want to go outside and get some sunshine. So you take your notebook or your tablet or your smartphone with you outside and you think, I'm going to work on that report out here in the sunshine at the park instead of being in my office. Could you do that? Well, you could if you once again installed that application locally on each of those devices. And if you had a workstation at work, a notebook system that you traveled with, a tablet system that you used just for fun, and a smartphone system. Then you would actually have 4 different copies of that same application to use all of these different devices to do your daily work. Well, with cloud computing, we take away this whole concept of locally installed applications. But there's more to it than just applications. When you use the cloud, you use a network connection, and you connect to either a public cloud on the internet or a private cloud provided by an organization and then run the application out of the cloud. In other words, the application runs on hardware provided in the data center instead of over here on the local devices. And this is nice because I can run that application from the desktop to my computer at work. And when I go home and I get that call at night and they say, "We've got a problem and you need to get this report done immediately," I can just use my laptop at home or maybe my home computer and connect to the cloud, run the very same application, and access the same data because the data is being stored in the cloud now, not on my local hard drive. And then if I'm having one of those spring fever days and I want to go to work at the park instead of in my office, I can sit out with my tablet and once again, I can access the application from the cloud. I can work on the very same data that I was working on for my desktop system at work and accomplish the same thing without having to install that application or copy the data I'm using on each of these different devices. Now, as I said a minute ago, cloud computing comes in different forms. We have public clouds that can be accessed by anybody. We have private clouds that are provided by a particular organization, and access is restricted to just that organization or to other paying clients who want to use it. And we have hybrid clouds, which kind of combine the best of both worlds, public and private. Cloud services include the delivery of software, infrastructure, storage, or a combination of all three in a complete package over a network connection. And that network connection could be within your organization on a LAN, or it could be an internet connection to a cloud that's available on the internet. From the user standpoint, the great thing about the cloud is its flexibility. The fact that you can use whatever device you want from wherever you're at and have access to the resources you need without having to install and set everything up manually. Clouds are also very attractive to management and to business owners because clouds are elastic in nature. And this is very key. Basically, users can request resources on demand and then just as easily deprovision those resources when they're done with whatever they needed them for. Let's take a look at some of the other benefits and features cloud computing offers. The first is self-service provisioning. Self-service provisioning means that your users can easily get cloud services without having to go through a lengthy approval process. Basically, your users just request the computing power, the storage space, the applications, or whatever it is they need from the cloud service provider. And within a matter of seconds or minutes, they have those resources. In addition, clouds also provide APIs, which basically provide a means for resources stored locally to communicate with services provided by the cloud. For example, you may run an application out of the cloud that needs to update a database that's stored in your organization. With APIs, you can do that. Clouds also provide metering because it's kind of a pay-as-you-go type of system. The cloud provider has to decide how they're going to bill for the
Yo, I was doing all this talking, I was breaking it down, and then only to realize the mute button was on. Okay, so this is what I said. So let me explain API, Application Programmable Interface. All right. So application programmable interface, we kind of talked about it before. These that we talked about port numbers, which I said are doors on the network. Okay. So a port number is a door on the network. So your IP address tells you what road to take to get to your destination. When you get to that destination, you have to enter into a particular door. So that meant to deliver that message could be you as the physical person, or you could be dropping something off to somebody. Same thing with our email and when we try to access the internet. Okay. So the port number, so your IP address 192.168.1.1, and the port number, port 80, is going to be the door on the network. Okay. Your application programmable interfaces are ports 135, ports 136, 137. I hate when I do that. 137, 138, and 139. So these are the doors on the network that are what we refer to as application programmable interface. What does an application programmable interface do? It accepts and rejects requests. Okay. What do I mean by request? When you want to purchase a video game, you go on a PlayStation Network. That PlayStation Network has an API that will accept your request so that you can The best way that I used to kind of break it down to students is I'm gonna draw this line in the middle. On this hard drive is going to be the network, okay, that we want to access from. So I'm just put PS for PlayStation. So this is PlayStation's hard drive. Now there are port numbers that allow requests through. Okay, this is more actually kind of CISA plus, more CISA plus. So I could be sitting over here and sending all these different requests through the network. My goal is I'm requesting information so that I can gain access to request stuff from the hard drive. Okay. These are my APIs. This could be port 135. And it's hard to draw with this thing. This could be 137. This could be 138. And this could be 139. All right. So me as the outside entity, I'm always sending information. So we also call these, let me get back to not drawing, but typing. Draw. All right. So I could be these, we also call these intermediaries because they're really not ports. All right. They're intermediaries. Their whole goal is to allow the requests to come through the network. And then the goal is to gain something from the hard drive, from the internal company's hard drive. Okay. So this is what an application programmable interface does. It's the open interface on the network. And most hackers know that these ports are always open. Okay. I'm going to give you another name for this. Okay. Another name for these ports is called the net BIOS. Okay. So the net BIOS is also another name for APIs, your application programmable interface. All right. So please make note of that. Ports 135, 136, 137, 138, 139. They are APIs, interfaces that allow requests or messages to come through. Now, just to give you another caveat, there's a job that a certain person can have called a vulnerability analyst, where what they do is they assess the messages that come through these intermediaries. You might see the guy or the person, I'll say it that way, in the grocery store, and you may think they're just looking at their cell phone, but really they're looking at their computer at home, and their computer at home is analyzing network traffic. And so what it's trying to do is make sure that no vulnerabilities are coming through these intermediaries. So whenever you hear the term API, know that those are open ports that allow requests from that. Anytime you go access your bank, it's got to go through an API. Anytime you send email or you request to purchase something online through Amazon, that message may go through the API, the application programmable interface. Okay? All right. So let's get back to this.
The service. It's not like the old system where we purchase the hardware and we purchase the software and then use it. You pay for what you use, and so they provide a tracking system to bill you for what you have used. One of the key things that makes cloud computing so beneficial, aside from the self-service provisioning, is the fact that cloud applications are designed to be easy to use. This is very important. Your end user should not be intimidated by the concept of using a cloud resource. The infrastructure underneath cloud computing may be really complex, but the end user interface, generally speaking, is relatively simple. So the user says, well, I can just open up that application in my browser and do what I need to do, and they don't have to worry about anything else. With this in mind, now we need to discuss the cloud service delivery models that are currently in use. There are three of them you need to be familiar with: infrastructure as a service, platform as a service, and software as a service. Let's begin by taking a look at infrastructure as a service, or IaaS. IaaS is the delivery of what we traditionally associate with computer hardware as a service. It provides storage as a service, as well as computing resources as a service. Essentially, you can rent storage space in the cloud instead of having to go out and buy a whole bunch of hard drives that you install and use locally. Likewise, you can use computing power from the cloud instead of having to go out and buy new high-end systems to do a particular job. You simply rent time from an IaaS cloud service provider. That way, you don't have to go out and buy that hardware. This saves a lot of upfront money on purchasing hardware, and it also provides the flexibility, scalability, and elasticity that we talked about earlier. If you end up with a project that requires a lot of storage and a lot of computing power for a limited amount of time, you scale up. And when you're done with that project and you don't need that computing time anymore, you scale back down, so you only pay for what you need. Platform as a Service, or PaaS, offers a complete development environment. Basically, it's an environment that you can use to create cloud-ready business applications. The cloud service provider delivers an entire solution stack. This solution stack is an integrated set of software that provides the developer with everything they need to build an application. And this is really kind of an outgrowth of the traditional concept of web hosting. If you've used a web hosting provider in the past, you know that most of them provide you with some kind of web development interface that you can use through a web browser to build your web page. This is the same type of thing, just on steroids. Instead of just being able to build websites, it provides you with a complete development environment to develop entire integrated suites of applications. And once again, the primary benefit of doing it this way is the fact that your development and deployment activities take place entirely in the cloud. So you don't have to manage or maintain local systems because it's all done for you by the cloud service provider. Some cloud service providers will provide you with development process features like software design, software development, testing, and deployment. Just as with infrastructure as a service, Platform as a Service provides you with the flexibility and the elasticity you need to scale up when you need resources and to scale back when you're done. Software as a Service, or SaaS, is really designed more for your average end user. SaaS provides end users with business applications that they need to do their day-to-day work. Instead of installing the application locally on their hard drive, they simply open a web browser and go to their cloud service provider. And within that browser, they run whatever application they need to use, word processor, PowerPoint, spreadsheet, whatever it is they need to do. This was one of the first implementations of cloud computing. And, as I mentioned earlier, without cloud computing, if your organization hires 20 new people, and all of those 20 people need to use a word processing application, meaning the application on each of those users' computers, you had to purchase a copy and install it. Whether or not the application is used all the time, part of the time, or never, you still had to buy the software. That's the advantage of SaaS. You only pay for what you need. If the employee uses a word processing application 8 or 9 hours a day, you pay for it. If the employee uses it 3 hours a month, that's all you pay for. One of the key advantages of SaaS is that you can try new software without committing to it. Try out an application on a rental basis, pay for the time you use it. And if you really like it, you can go ahead and use it more. If you don't have to spend any money on it. Before we finish, there's one other thing you need to understand about SaaS. SaaS comes in two forms, simple multi-tenancy and fine-grained tenancy. With simple multi-tenancy, each customer of the cloud service provider has their own resources that are completely segregated from other customers. And you can do this, but it's a relatively inefficient way to do things. Fine-grained multi-tenancy is more efficient. It offers the same level of segregation as simple multi-tenancy, but all of the resources that are used by each customer are shared. Your data is segregated, so nobody else can see it, but your computing power and applications are shared. With simple multi-tenancy, you essentially say, I want to purchase this chunk of resources, and whether I'm using them or not, no other cloud customer can use them. You basically share and pool the resources so that nobody hogs them. And that's it for this lesson. In this lesson, we talked about how cloud computing works, we defined cloud computing, and we looked at 3 different types of cloud computing: infrastructure as a service, platform as a service, and software as a service.
All right, everybody. We're gonna after a 12-minute video, we're gonna freaking put this on a pause. And we're gonna end class here. Are there any questions before we stop? Since there are no questions, I want everybody to review the content that we went over today. I will make sure that the quizzes are available for you to go through virtualization and cloud computing. And I'm sorry. And I will see you all on Wednesday. Remember, at the top of Wednesday, we will start with the simulation. Okay, just so
I
that
have a
you'll get.
question.
Oh, go ahead.
You gonna put them on your you gonna put that the recording on your
I
YouTube
have
page?
to, after a video this long, all these out, I have to go through, and some stuff I may have to cut up. And so, what I mean by that is, with Test Out being proprietary, I may have to cut out their videos. And I could put us talking and us going over things, but I may have to cut their stuff out. I'll post it and see, but you know, and then y'all, like us talking and having this conversation too, I have to cut that out of the video as well. Something about Maryland law. Maryland law doesn't allow certain things in the classroom. So once I go through it, edit it, then I'll post it up. Okay. And it will be on the Sure Cyber website. It won't be, I'll put a link in the classroom, but it'll be on the Sure Cyber website. Okay. Since there are no further questions, everybody, one reason why I don't like recording videos, because people will go off and do something else and then want the video to, you know, stay abreast. And I want your focus during class. But anyway, all right, everybody, you have a good one. I will see you next time. Go get some rest.
Thank you. Good night.
Good night.
Thanks. Bye.
Good night.
Hey,
Good
I
night,
like that,
everyone.
Darren. Good night. APIs are like waiters that act as the interface you interact between you and the kitchen at the restaurant. Yep, I like that. That's good. Well, good night, everyone. No questions for you guys? Not. Have a good one.